In this lesson, we're going to go over some new terminology for describing the different relationships between the classes in your programs, and then we'll see how we can diagram those relationships using UML notation. At the beginning of this course, we used interfaces to add an acceptability behavior to our MoneyCard program from the previous Java 201 course. That MoneyCard program had many different relationships between the superclass and subclasses and the interface. Now, usually when creating your own program, you'll want to define these relationships before beginning to implement the application to help with visualizing the program's class structure and identifying common functionality between the classes. So there are several types of relationships, but I'm going to cover the four main relationships that can exist between your classes. We have a is-a relationship, the realization relationship, the has-a relationship, and then the uses relationship. The is-a relationship is used to describe inheritance, also called a generalization. We learned about inheritance in the previous Java 201 course when we created the MoneyCard superclass and its subclasses, credit card, debit card, and gift card. So we can define the relationship between a superclass and a subclass by saying that a credit card is a money card, or a debit card is a money card. So you'll use the is-a relationship to describe the relationship between a superclass and a subclass. Now, the realization relationship is used to define the relationship between a class that implements an interface or a component. So from our MoneyCard program, we have an accepted everywhere class, which implements the acceptability interface. So we can say that our accepted everywhere class realizes the behavior of the acceptability interface. Now, the has-a relationship is used to describe the relationship of when a class has another class. An example of this would be from our MoneyCard program. Each MoneyCard has an acceptability behavior defined as an instance variable. That could be a credit card has an accepted everywhere class, or a gift card has an accepted select locations class. This has-a relationship is also called aggregation. So in other words, we could say that a credit card object aggregates an accepted everywhere object. Lastly, we have the uses relationship, also called dependency, which is when one class's method uses or depends on another class. An example of this would be again in our credit card class, which not only has an accepted everywhere class, but it also uses the accepted everywhere class to call its location method. So now that we know how to identify the relationships between our classes, let's take a look at UML notation for creating a visual diagram of our classes' relationships. So here's a UML diagram that I created of the relationships between the classes in our MoneyCard program. Now in the next lesson, I'll show you how to actually use this program to create a UML diagram. But for now, we're just going to take a look at the notation so that we can learn how to read the diagram. So each class here is represented by a square with the class's name on it. Now you can draw these class squares just by selecting the little square button up here to create a new class. And you can see that we have all of our classes laid out here, as well as our acceptability interface on the right. You can draw interface squares using the interface tool right here. Now the different lines that you see, each line is a little different, and they each have different symbols at the end. These lines define the relationship that the class has with the other class or the interface. Let's start on the left side here. So we know that a credit card is a money card, and this generalization relationship is represented by a solid line with a triangle on the end, and it points from the subclass to the superclass. So I've also defined this same relationship of a gift card is a money card and a debit card is a money card as well. To draw this generalization relationship, you can use the generalization tool up here at the top, and that'll draw the line with the triangle for you. Let's now move to the right side and take a look at our acceptability interface relationships. So we have our accepted everywhere class and our accepted select location class, and both of these implement the acceptability interface. Now this type of relationship is called a realization and is defined by using a dotted line and a triangle at the end pointing to the interface that the class is implementing. So you can draw this type of relationship using the realization tool right here. Now in the middle, we have our aggregation relationships. And this is where a credit card has an accepted everywhere behavior. And the same is true for the debit card class, and then the gift card class has an accepted select locations behavior. So the aggregation relationship is defined by using a solid line and an unfilled diamond on the end, with the diamond pointing to the class which has the other class. So the credit card class has an accepted everywhere behavior, so the diamond points to the credit card class. Now you can draw this aggregation relationship using the aggregation tool right here. Now you may be wondering why there are no uses or dependency relationships here, since we know that a credit card uses an accepted everywhere class. You'd think that we would have some type of uses relationship showing here. But since we already have this aggregation relationship, this also implies dependency, and so there's no reason to have both notations. But if you do need to create this type of relationship, you can use the dependency tool right here. And that's it for the basics of modeling your class's relationships using UML notation. I hope you found this helpful. Next up, we will be taking a look at using all of the techniques that we've discussed in this section at once to see them in practice. But that's it for this video, and I'll see you in the next lesson.